Oh, it's recording.
You can put the button up.
It's recording.
She's so far away.
Okay.
No, we need a presentation in there.
Do we need her legs?
No, just have
It's perfect. It's perfect.
Okay, I trust you.
He knows it was me.
Dude, let me know if I step on your toes.
Hey, trip this man.
Look at those fancy shoes. Let me get a pair.
Fancy shoe that's made to be scuffed.
No. We're not duped. No, I bought some nice and clean and pretty. I'm the one that's done it.
You're making it.
I know, and we were like, what is that?
Thank you. You need to get smart.
What do you think I should practice? One of my friends says, we honor those who come on time by starting on time. Amelia Willis is a third-year senior. From Houma, Louisiana. And she loves robotics. And next year she will matriculate to Louisiana State University at Baton Rouge to study mechanical engineering. And she came to me last year, and in Amelia's style, Mr. Bergman, I want to do a distinction. And she had this fully formed idea that is pretty much what you will see tonight, where she's taken some of the cutting-edge technology and applied it to real-world needs. And this is more of what we need in our world. So, I'm very proud to announce to Amelia Willis.
Like Dr. Bergman said, I'm Amelia Willis. I'm a third-year senior, and thank you for coming to see my distinction in computer science today. Today, I'll be telling you guys about empathetic response generation according to live emotional recognition and effective computing. If you don't get any of that, don't freak out yet. By the end of this presentation, hopefully you'll have a better understanding of artificial intelligence and effective computing. The first section is the introduction, which covers the goals and important definitions, the process, and how I made the software. And then the results of the study. When you guys look at these images, how would you label them? And more importantly, if you saw someone with these faces, how would you interact with them in conversation? The purpose of this distinction is to create an artificial intelligence-based software that can read emotions like these and respond accordingly. My research aims to bridge the gap between AI models trained for facial recognition and AI models trained for By combining the two forms of unique models, users will be able to hold conversations with AI more naturally. The model will adjust live to the user's detected emotion. I achieve this goal with a live camera feed that maps and evaluates the emotion on the user's face, an integrated chatbot, and a server-based web application that combines all of it. The motivation behind this was my discovery that chat systems between a user and an emotionally intelligent AI model can result in frustration from the user and inaccurate responses from the model. When used in situations where the purpose of communication between AI and humans is to provide social and emotional stimulus for the user, like an elderly interaction with patients whose conditions improve with social interaction, it is of the utmost importance that effective computing is used properly and effectively. If an artificial intelligence model is able to recognize a variety of emotions such as frustration, sadness, or happiness when communicating with the user, the combination of machine learning, natural language processing, and empathetic response generation will be able to better adjust to the needs of the user. So the beginning of every good computer science project like this starts with the data. My data was taken from a website called Kaggle, and there's a lot of it. It contained 35,887 grayscale images, like the ones y'all saw a couple slides ago, and I needed to teach my software how to label emotions on a human's face. But first, those emotions had to be labeled themselves. The data set I used is based its annotations of emotions for each image off of Paul Ekman's basic emotions theory. It states there are 6 universally expressed emotions similar across all cultures, plus 1 extra, making a grand total of 7 emotions: happiness, sadness, anger, frustration, disgust, surprise, and fear, or neutrality. Before we dive any deeper, I wanted to explain a couple of concepts that are crucial to understanding a bit more about artificial intelligence and machine learning. So first, while there is no standardized definition of artificial intelligence due to the wide variety of tasks and outputs it can perform, the general scientific consensus is that artificial intelligence is a technology that enables computer systems to perform complex tasks typically completed by human reasoning. For all our intents and purposes, I include the Oxford Dictionary definition, particularly focusing on the yellow. Next is facial recognition. This isn't just another concept used in sci-fi movies. It's a pattern-based recognition system, and first the human face is reimagined as a coordinate plane, with your facial features having various XY coordinates. This facial plane is used to analyze and map out a person's features in a mathematical representation to store and retrieve at later convenience. Facial recognition is a game of patterns and matching. So once a system is trained on the approximate coordinate combinations of different emotions, like where your mouth and your nose is placed in certain emotions, like happiness or sadness, facial recognition can be used to determine the emotion. Another extremely important concept in my research was coined by Rosalind Picard's 1995 paper entitled Effective Computing, effective with an A. Effective computing is the process of training AI with the intention of labeling the recognized emotion the same as a human would label it. Picard detailed the benefits technology systems receive if they were able to interpret the emotional status of the human user and adapt their responses appropriately. With the ability to detect and recognize emotional information in both the data and the artificial intelligence system has been trained in, the live input that the user of the program is providing, the goal of effective computing is to label the emotion or pattern the same as a human would regard it. So in this photo, the computer would look at the image, it would label it as happy, but it would also check that the previously determined label matches the same way. So happy and happy both. So now to the concept of machine learning. Machine learning and language learning models are the backbone of artificial intelligence response generation. Machine learning is what allows artificial intelligence programs and computers to learn organically without a set of programming instructions to follow. It's a subset of artificial intelligence that focuses on building algorithms capable of learning patterns from data and making predictions or decisions. Some of my favorite applications of machine learning are technological and product advancements, like sports betting predictors, spam email detection, and live chatbot systems, like ChatGPT and Gemini. There are 4 main steps of machine learning: tokenization, interpretation, reinforcement learning, and then the product. So first, tokenization. It's built upon the belief that every response or conclusion generated by an AI first begins with an input. This input acts as the sensory information from the outside world or user into the AI. This input can come in forms of text, speech, images, etc. After all input is received, the AI must break the information down into readable chunks through different processes. For text, there's tokenization and normalization, which converts the typed phrases into words and standardizes their case, while for video, audio, and images, feature extraction and noise reduction is prioritized. In the above example, each chunk of the sentence is broken down so it's able to be interpreted both individually and within the context of the larger sentence. So the sentence, hello, welcome to my distinction, is read by the computer as hello, comma, welcome to my distinction. And of course, hello would no longer have a capital letter because of the normalization throughout the chunks. The chunks put information on a level playing field to the computer. In the interpretation step of machine learning, the chunks are then further analyzed to determine a meaning. So in the sentence we used before, hello is interpreted as a greeting. The comma is seen as punctuation. Now, welcome is where things get tricky. There are several possible meanings. It can be a greeting, as in welcome to my home, a response, as in you're welcome, an adjective, as in you are welcome here, or a verb, as in I welcome feedback. But when evaluated in the larger context of the sentence, the meaning becomes clear. To can either be a preposition that shows direction or an infinitive marker that signals a verb. Punctuation has low emotional weight, but high structural importance to the AI. My indicated ownership, and last but not least, distinction. It's recognized as a noun, either meaning difference or academic honor and research. But when the rest of the sentence is linked to determine the definition, academic honor or research become clear as the true meaning. Completing the collection of input and interpretation of the data is only the first half of the artificial intelligence response system. In this project, a language learning model is used so that AI is continuously improving upon itself. And this method of training has built-in learning and feedback loops, which allows the artificial intelligence system to become more efficient over time. Since the model is able to be trained on text, images, videos, audio, etc., all that is required is a pattern in the data for the computer to analyze and draw conclusions from. This reinforcement learning cycle that I have diagrammed above starts with an input, aka our data set, that is run through the model, which makes a guess about the emotion, and then is sorted as right or wrong. So the computer is given an example emotion from one of the random 38,000 images that we saw earlier, and then it makes a guess on what the regular person has annotated this image as. So if the image is of a happy emotion and the computer guesses sad, then it's marked as wrong and the cycle is restarted. But if it guesses correctly, then it is marked as right and the cycle still restarts. The cycling in this training process is called backward propagation of errors, also known as backpropagation. It's an algorithm that trains artificial intelligence models by calculating the difference between predicted and actual outputs and minimizing it through rounds of training cycles. The error rate of the training model is found using a loss function, which I have graphed above. A complete training cycle, which is the near 38,000 images mentioned earlier, is called an epoch. In an epoch, the sample is processed, the model completes the loss, and the parameters are updated accordingly. Multiple epochs are typically required so that the model can iteratively refine its weights and improve accuracy over time. The following are the different loss functions, and the graph from a 50 training cycle epoch is shown above. This was the first training epoch cycle I ran, so it went down from 0% accuracy to eventually, after running 38,000 images 50 times, it got up to 45% accuracy. Now, I'll make a disclaimer, this is not the only training cycles I run. To current day, I have ran about 140 epochs, and these epoch training cycles take a long time because they're going through this 38,000 images. So running epochs at night were my best friend throughout this process. This is an example of the 5 training cycle. So it takes it from up to 42%. Now, 5 training cycles are not typically enough to properly represent how the accuracy develops develops, but for this purpose, I ran 5 training cycles just to see what the difference it was on how versus a 50 training cycles versus 5 training cycles. And then this is my 30 training cycles that reached me into the final accuracy on my distinction paper, which was 73%. After the indicated rounds of development are completed, the model is able to be used. As more rounds of training are completed, the model becomes more successful. Now that the data analyzation was complete, it was time to ensure that the research had live predictions by camera. Using lots of computer science with dictionaries, JSON files, and 3 different coding languages, a CV2 video capture, and a loop while true function, it continuously reads the emotion on the face of the user through the live camera. The identified face is then squared with a green box and the predicted emotion is labeled above. So here is me in my dorm room on one of my first trial runs. That was the happiest screenshot you're going to get in a while because I had so many errors before that. Finally, to complete the second part of my project, which was the integration of a chatbot system, I had to branch into Flash servers. A Flash server is a web framework written in Python that allows users to interact with AI applications via a website. The advantage of using a Flash server is that the created emotion model can be integrated into an AI chatbot system and displayed by a web application and server. The web page for this project was successfully created through a combination of HTML, Java, and Python that all provided different functions. To integrate an AI chatbot system, I use Olama, short for Omni-Layered Learning Language Acquisition Model. It's just a platform used by developers for small-sided projects. The model was pre-trained and open-weighted, which made my life a lot easier. So I will be conducting a live demonstration, and I'd like to invite on stage Olivia Lubert to help me do this live demonstration. I'd also like to provide a disclaimer at the moment that I apologize if any technical issues arise. Beforehand, we did have an issue with the Olama on this specific server in the recital hall, so right now the only thing up for live demonstration is the facial recognition. So if you just give me a moment to set that up, that'd be great. This is my biggest code fail.
Just too short.
Okay, awesome. So I'll also have this running at the end of the distinction if anybody want to try it out. But Olivia, if you'll just cycle through a couple of emotions for us. When it hits happy, you need to tilt your face down. Yeah, thank you. Okay.
Tilt your head down.
Yeah, look down. Thank you. Oh, there you go. You got the sad. She's really good trying for these guys. Can you get angry? If anybody wants to give a try for some of the emotions that maybe you can make with your face. Okay, thank you, Olivia, for coming to this.
I like people like
Wow, that was great. I really didn't want to have to do it myself. Oh! That's not what I wanted. as well as the emotions inputted by the user's facial expressions. It has been subsequently sent to the llama response generation software. The software successfully completed its research task and contributed empathetic responses as outlined in the research goals. So as you can see in this photo, I am obviously showing a sad emotion, and then I typed in the chat bot, "How are you?" And in this one, I went through that conversation and asked, like, how can you make your day better, that kind of thing. And then in this one, I'm happy, so it says I'm doing better now. And the chat bot goes, "That's great to hear. It's amazing how even small steps towards feeling better can make a big difference. I'm so glad you're feeling more positive now." You get the gist. So, the results of my research were positive. Over the course of 82 total training sessions on the AI model at the time of my distinction, the emotion was correctly recognized 73% of the time, as shown in the above figure, with an average loss value of negative 0.069, which is pretty small in the grand scheme of things. Now, a couple problems and limitations I ran into. 73% doesn't sound like a huge accuracy value, but due to processing power and stable Wi-Fi connection limitations, especially at school, it was difficult to increase the epoch total accuracy past that. But in the future, with a higher duty computing machine, increasing the accuracy percentage is a priority. One more technological limitation that I'm sure you guys noticed in our demonstration is that some of the emotions are more easily recognizable than others. And this comes down to my data set. The data set, it has more images proportionally of happy emotions, sad emotions, and shocked emotions than the other four. So those were the emotions that had the highest accuracy. So if you were to split down my epoch total data on which emotions had the highest accuracy, the happiness, sadness, and shock would present as the most accurate. So, as you guys can see, effective computing is the future of artificial intelligence. The research done in this distinction is just a taste of where this field is able to expand into. The study has proven that through emotional recognition and facial expressions, artificial intelligence can create successful, empathetic responses to further improve AI-human interaction. Any questions? Okay.
Could you add a way to get like tone of voice, like be able to actually talk to it and add tone of voice into the data set also?
Yeah, that was something I looked into at the beginning of like my planning phase, if I wanted to take vocal tone and inflection into account, but there is not a whole lot of data on that, especially because inflection patterns in English vary drastically by region. So a lot of the data that I found was from northern regions, and southern inflections that determine the emotion that you're feeling are very different in the south than they are in the north. So it could have been done, but it wouldn't have given me the results that I wanted. Anna?
I've like heard how in some facial recognition softwares, it like based on the data sets it's trained on, it doesn't pick up like other races and facial structures as well. Did you run into that problem with yours?
Yes, I did. So shout out to my roommates, Anika Chegaretti and Monique Garlapati. This was a problem I faced. The data set that I used was not majority, but it was probably about 60% white and European features. So the accuracy on non-white features was lower. And I had a really hard time figuring out why that was until Anika and I had a conversation one night last semester during our data analysis through the humanities class. And we figured out that, we went through the images and we figured out that it was definitely the features and the coordinates that it's trained on, because this happens if you have features that aren't typically proportional, specifically. So if your mouth is wider, then it won't perform as well on you, because the standardized coordinates that the emotions is trained on just aren't as present on your face as they are in others. Probably the first time it worked. A lot of computer science people can attest to that. Seeing error after bug is really discouraging, but the adrenaline rush you get when it works for the first time is probably the best thing ever. I remember screaming in my roommate's coming in and being like, what just happened? So that was pretty funny. Dr. Bergman?
When someone asks a question, would you repeat the question?
Oh, okay. Awesome. Any more questions? Okay. Yeah, Luke.
So as I mentioned earlier, that the artificial intelligence had issues putting up emotional expressions on the basis of people with other races. Could that be improved by solely increasing the training data?
Yeah, of course, that's exactly how you fix it. I would have to take more images in a 38, I'm sorry, the question was, would improving, helping to improve the amount of the accuracy on different races, would a way to improve that be increasing the data set size? So yes, it would be increasing the data set size. It would just have, I'd have to format it to that similar data set, so it would have to be 42 by 42 pixels, grayscale. So just increasing the data set size will always make you more accurate, no matter what data analysis project you're doing. Yeah?
Do you plan on like doing more like runs with the epoch, or like to make them more accurate after?
So do I plan on doing more epoch runs? I do. So like I said, I had 80 epochs around when my distinction was turned into like Miss Annie in administration. At this point, I have like 140 epochs run. I was planning on having a lot more than that done by this distinction, but vacation kind of ruined that because all my stuff is here. But just from when I turned my distinction in to my accuracy now, I think I raised like 7%. But one thing you have to keep in mind with the epochs is the higher accuracy you get, the more epochs it takes to keep improving at a constant rate. So while I jumped 60% accuracy in 30 epoch training cycles, I ran a 40 training epoch cycle a couple days ago and I only jumped like 6%. So you have to keep that in mind. Lila?
I know you mentioned that like the epoch, with the training and stuff, like so original and where you're running overnight. Like what percentage of your total working time on this project was taken by like just the testing?
How much of my training time, how much of my distinction work time was taken up by the epoch training cycles? Honestly, I have no clue because whenever the epoch was running, that was like my break. So that was when I would like do my homework and all that kind of stuff. So I really didn't include it in my distinction work time. If I had to guess though, I probably spent well over 10 hours running epoch training cycles. Sean? So I can change how long does each epoch training cycle take? I can change the amount of epochs run. So if I know I only have like 2 hours between classes, I'll probably only do like 15 epochs, especially at this time because the accuracy, it takes longer now. But it really just depends. I kind of have like a sense for it now, but there's no definite like equation or cycle time. Luke?
Do you have any advice for someone trying to learn to work on AI?
Any advice for someone who wants to learn, like to work on AI? When I was first starting this project, I didn't have a lot of experience in AI, and the website Dr. Bergman sent me to learn more about machine learning and artificial intelligence software development was Kaggle.com, and it basically just has a bunch of like competitions that you can enter and learn a bunch of things from. It gives you their own data sets. So if you're specifically interested in stuff like using data analyzation and artificial intelligence, Kaggle is a great website to do that. But when just learning about regular AI and like, as with all coding, you kind of just have to dive in. When I was younger, I had a lot of like books. That's kind of boring, so like you could do YouTube videos now. Noah.
Do you plan to keep working on this?
Do I plan to keep working on this? I'm going to LSU, like Dr. Bergman said, and one of the main people involved in my distinction was Mr. Neil Kilgore, who was here last year during the technological conference that was held here. And at the beginning of my state distinction, I had a bunch of questions for him about machine learning and artificial intelligence. So once I figured out I was going to LSU, it became pretty clear to me that I was probably going to try and go for a position with Mr. Kilgore. So I hope so. I want to continue this type of research. I love it. Bianca?
How long have you been doing computer science for?
How long have I been doing computer science for? I started learning C++ when I was 9. Yeah. I did a lot of Arduino until I was about 12, and then when I was 12, my dad stuck me on code.org, and I sped run everything. So that's when I really started to learn Python. And then when I came here, I learned Java because that is the programming language we use for the robotics club. So now I would say my most the three I kind of focus on is Python, C++, and Java. My C++ is kind of rusty now though because this project was written entirely in Python and the robot is all in Java. So I haven't really had a chance to flex my C++ that much. So. Any questions? Doug?
So for your project, how would you specifically make it to where it identifies specific blendings of emotions? And then how would the chatbot prompt questions about those specific blendings of emotions?
So the emotions aren't necessarily blended together. It's how does the chatbot use blending emotions to figure out what the question and how to respond to it is. The emotions aren't necessarily blended as much as the one that is shown most is the one that is focused on by the AI chatbot generation system. And the way it works is basically the emotion recognition takes place, and then that sends the emotion over to the chatbot, and the chatbot is trained on empathetic response generation, so effective computing. And using the emotion that it was sent, it then prompts a empathetic response. So similar to how if you see someone crying in a conversation, you'll be like, oh, what's wrong? Not like, I'm so glad you're having a good day. It's the same process. And
So if you had to do this again, what would you do as the process differently?
I think, what would I do differently? I would probably expand data set size because the data set I used was the most common emotion recognition data set, but there were some limitations. Like you guys saw the pixelatedness of these emotions. So the coordinate plane mapping wasn't as great as it could have been. So I wonder now, if I had used a data set that had a higher image resolution, if it would be more accurate, or if I had to get less epochs to get to the accuracy I have now. So probably a different data set. Caleb?
What was the biggest hurdle in the coding process?
What was the biggest hurdle? Just because all of this is done in multiple different files, so honestly, probably the callback transition between the files. Making sure they link together properly, making sure your paths are correct in your file folders. That was probably my biggest struggle, but that's just because I go straight to what I think the most niche problem is, and I don't really think about the big picture. So that's more of a me problem than this code specifically. But once I figured the file folders and all out, and the emotion recognition camera worked for the first time, everything was pretty smooth sailing from there, honestly, because I fixed the big bugs early. David?
If I say in the chat, my dog died, or something,
What did you say?
I say something conflicting with my emotions. I'm smiling, but I type something super sad. Which one does it value more?
That's a good question. I don't know the exact answer to that. Knowing just the logic of the programming system, what I would assume would happen is it would take the average, honestly. So it would sum them together, and then it'd probably end up somewhere near a neutral response. Just because it's not entirely sure what you're doing. Anybody else? Yeah.
Would it be possible to capture certain sub-levels of a particular emotion, like anger or sadness, for example?
Can you rephrase that?
Well, you have depression, or just you're just sad.
Oh, okay. So the severity?
Yeah.
Okay, how would it address the severity? I think that is also just a data set solution. You have to train it on minuscule differences, but I think the accuracy would be really low on that because, once again, people would display it different ways. Depression, like on face, isn't displayed the same way across most people. That's why using the Paul Ekman annotation system was really beneficial for me because you break it down into 7 categories, and that's all you got. You can't necessarily do the severity of it just because it displays itself differently on people. Jaka?
So like in a situation where, oh, you're smiling, but you say sad stuff, and you're giving like a neutral response, so you try to like ask questions or try to figure out more how you're feeling.
Yeah. So as you continue the conversation, it would try to steer itself in that direction to figure out what's going on. Anybody else? Okay. Well, I'd like to finish out with my acknowledgments. So first, thank you to my mentor, Dr. Berkman. I came to him junior year, and I was all over the place. I guess he viewed it as I had my stuff together, but I definitely did not. So thank you for taking that chance on me. I'm really appreciative of it. And I'd like to thank my readers, Ms. Peters and Dr. Bowden. They helped me a ton during the process. Dr. Bowden especially with my grammar because it was horrible in mine. Just shout out for that. Thank you to my peers, staff, and administration for making today possible. And thank you to my friends. And finally, thank you to my family, my mom, my dad, my brother, for always encouraging me and supporting me. And one last shout out, Dr. Landry, because my sophomore year, I was like, oh, I want to do a distinction. And I was like, Dr. Landry, what are you even doing? And so she kind of pointed me in the right direction, and that's kind of why I'm here today, honestly. So thank you, Dr. Landry. Thank you for everybody for coming out. And I'm going to boot up the camera if anybody wants to check out their own facial expressions before you leave. So thank you guys for